am not the only person that you need to get familiar with. You also need to get familiar with development kits, or dev kits. So dev kits, one way of thinking about them is jailbroken PlayStations. They're basically PlayStations that we use internally for testing or for development. Another way of thinking about them is just a device that allows you to install uncertified software, so software that we haven't made sure isn't going to accidentally like destroy or brick the kit. So I'm going to talk a little bit about the history of Skyfarm, which I've broken down into 4 eras. The before times, so before we had almost any automation, how did we manage our kits then? And then I'm going to go into the origins of Skyfarm. So when did we actually start automating and managing these kits in an automatic way? And then when we actually started automated testing, which was after we actually started managing these kits. And then finally productization. So when my team started building this system into an actual service that people can use. So in the before times, before we had any sort of automation at all, the way we managed kits was with vinyl records, literally physical vinyl records. So one team that we had in around 2008, late PS3 era, their product owner went out and got about 5 or 6 records, one for each development kit that they had on their team, for about 5 cents each. And so the way they managed them was they had these records out, and whenever you decided to use a kit for whatever reason, you would just go over, grab the record, and put it up in your cubicle, like this, so that everybody could see who had the record. So everybody could see who was using that dev kit at that time, so nobody else would use it. So a couple of years later, we had a developer who has a very common problem, or SDET who had a very common problem, which is that every developer thought that their PR was the most important, and this guy was in charge of testing all of these PRs. And so he would get a lot of calls from people being like, you need to test my PR next. And so he did what any good SDET would do, and he automated the process of checking out these development kits so that he could just get all of them at once, move between them very quickly. So he created a script that just allowed him to quickly check out those kits and move between them very, very quickly. A couple of years after that, around the end of 2013, we had a hackathon. We actually have hackathon roughly twice a year, where our developers can basically do whatever they want for about a week, work on any product, and at the end of that time, they get a prize, whoever came up with the best product or the most interesting product. And this team decided to automate tests on the dev kit. So they chose the name Skynet for their project, sort of as a reference to Terminator. And they actually won hackathon that year. So we started using Skynet. And from there, things went very, very quickly. So after December 2013, after they won hackathon, we then had the spin-up of the team that I now manage, which is Cyborg. And then we had the Skynet project sort of greenlit. We started doing a lot more testing. And the thing that I'm really going to draw your attention to here is towards the end of September 2017, so about 3 or 4 years later, somebody remembered we had this script lying around that allowed us to just like check out kits very quickly. Maybe we should actually use that and start like managing our kits a little bit better. So we had this script, and we decided to productize it. We had somebody say, all right, let's start adding features here. And if you're a developer and you start with a script, the first way that you're going to productize it is, at the very least, start turning it into a service. Whoa. So that's what we did. We started creating it, making it into a service, and that service initially only targeted development kits in California. But then we had teams in Tokyo and teams in India who both said, well, we also want this to manage our kits, so we added in support there. And then we had somebody say, hey, we want to be able to actually tag our kits with different capabilities, like this one is plugged in with a mouse and keyboard, for example. Let's do that, so we added that in. And then somebody said, hey, let's have this actually upgrade our firmware for us. So we added that in as well. And then somebody said, let's have this manage our users so that not all of the users can touch all of the kits at the same time. And then we had this intern just sort of lying around, And we said, hey, why don't you create a UI for this whole system? And so he did that, and then we hired him. And then somebody said, if we have devkits and we install bad firmware on them, they can go into this bad state. And so we were like, okay, let's try and figure out a process for automating that. And then we had scope creep. That's what we had, basically. We kept adding on more and more features, and over time, it just became this sort of monolithic mess, as you might expect from something that started as, just one guy writing a script to solve one particular problem, and turned into something that we started to use for all of our development, all of our automation. So, what did we learn? Well, we learned that you should gather your requirements. That's it. Thanks everybody. But in actuality, that isn't a very useful question, like what have we learned? What is a more useful question is what would we do differently? So this is a list of the questions that we would ask ourselves, and I'm going to be going through this list one by one and talking about the way that we learned these hard-learned lessons that we learned that made it into this list of questions, basically. So the very first question up here is one I learned when I was a kid from Jurassic Park and Ian Malcolm, which is not whether you should build this system instead of whether you can build this system. Especially when you work at a large corporation like Sony, you can build this type of stuff. But the real question is, should you? So the first thing that I would say is really think about that. If you have 5 devices, if you have 5 mobile devices, you don't really need a really over-engineered system to update firmware and set specific settings or whatever. That is probably not what you need. And use an existing system. Use Sauce Labs, use Headspin, use Browser Stack, use somebody who's already solving this problem that you can just pay to sort of solve this problem for you. I talked a little bit about the analog system that we used earlier, the vinyl records that we used for managing kits. And that may seem silly, but it works, right? Like, they're all housed in the same cubicle. You can look around, see who has all of the kits. It does work as a system. So don't overestimate the necessity of automating this type of thing. But let's assume that you do have to build this for whatever reason. You're sort of in a similar situation that we are. So the first question that you should ask is, how difficult is it to configure these devices? And what is the time that it takes to configure them? So for us, it's really difficult to configure our dev kits because you can't use images. We can't just load up a Docker image on a dev kit. That's not how it works. We have to actually make calls to settings to actually set those settings. And then when we set those, we then have to reboot the kit to make sure that those settings take effect. So that takes a huge amount of time. And when we set those settings, sometimes it defaults in other settings. So you have to reboot the kit multiple times in order to get all of the settings that you want. So it takes a huge amount of time to do. The other thing that you should think about is the latency of configuration. So for us, we have firmware that we install on these kits, and that firmware can be multiple gigabytes large, and the kit that it could be installed on could be on the other side of the world. So the latency to actually stream that several gigabyte file over to that kit and install it is huge, and that causes a huge issue. But the final thing that I have up here is discovery of settings, and this may be a very specific use case for us, but on mobile devices, if it's very easy to figure out what settings you need to set, then this isn't really applicable. But for us, we're not working in open source. We're not working on firmware that we can just dig and dig and dig and find open source code at the end and look at that. Even though it may not be ideal, you can at least look at the open source code. For us, you dig and you dig and you dig, and you end up in a Jira ticket that is written in Japanese. And you don't speak Japanese. So you need to find the one guy on the team who does speak Japanese and have him translate it for you. And it's been 10 years since he took a Japanese course, and they're writing in slang. And he doesn't remember the word for -1, so he's not quite sure if this is right. And if this sounds ultra-specific, it's because it is. It was exactly something that happened to me when I first started working on console. So that is one thing that you need to consider. How difficult is it to find the settings that you actually need to set on your kit or on your device? Another thing to think about is risk tolerance. So if you automate a mobile device and you accidentally brick it, that sucks, right? But you can run down to a hardware store, pick up a new device. It sucks, you're out a little bit of time, a little bit of money. If you brick a development kit at PlayStation, you're out the amount of time it takes to ship it across the world to the team that can fix it, which is who knows how long. And for that entire amount of time, you're out that kit. You just don't have it. So you need to think about that. So for us, the risk tolerance is extremely low. We do not tolerate risky behavior, which is why the hard reboot that we have for our kits is a last resort. Another thing you need to consider is the notifications when a device goes out of bounds. And by out of bounds, I mean it no longer responds to pings, it's just gone. So for us, it's really important that we find these kits as soon as that happens. So we have a Slack channel that gets updated every time a device goes out of bounds. For you, that might be different. You might just have an email thread or whatever. But consider that. Consider how important it is for you to know about those devices and to know when they go out of bounds. And the final one is configuration complexity. I've sort of talked about this a little bit or hinted at it already. But the configuration that you can have on these devices is really, really complicated. And so we also have to configure test users. So the system that we have for configuring test users and the system that we have for configuring devkits, thank you for turning on the lights, are two separate systems. Because the user configuration is really, really complicated, and you want to separate out those concerns. You also want to reuse that user configuration for other types of devices. For you, that might not be the case. Oh, somebody turned them off. Anyway, for you, that might not be. Okay. Okay. Cool. For you, configuring the device and configuring the user, it might be roughly the same thing. So you might just throw that all in one system. So consider about how complicated the different pieces are that you're configuring, and really separate out those concerns so that if you break one thing, you're not breaking the whole system. Yeah. Another thing is health. What is a healthy device? What is a healthy OS or firmware? If you're updating an iOS patch, what makes that iOS patch healthier than another one that may have come out, I don't know, a couple of days earlier? That's going to be different for everybody, and you should really define that. For us, this is going to get into one of the major misconceptions about my job. I work at PlayStation. Anytime I say that, somebody's like, oh, so you work on games? No, I don't. I work on the actual software that exists on the kit. So the PlayStation Store, that's the type of stuff that I work on. So we have internally a very different sense of health compared to the developers who are developing the games, usually in PlayStation Studios. So for them, it's critical that the device is connected to a monitor, which makes sense because they're actually testing a game. For us, that really doesn't matter. So that is an example of the wildly different definition of health that you might have between those two different areas of the company. And another aspect is that health of OS or firmware, as I sort of talked about. For us, we are getting multiple versions of a firmware every day. And so we have whole pipelines that are dedicated to just trying to figure out if the particular firmware that came out is stable or not, and we can actually start execution on it. For you guys, you might not need a whole pipeline to do that. You might just take a single device, upgrade it to that particular patch of iOS, run 5 tests on it, and be like, all right, that looks good. So it might be very different for you. So consider that and define it. Another example is privacy. So when we started working on PS5, not everybody could know in the company about that, which you would expect. So those people who were working on PS5 at the time wanted the same nice things that we already had for PS4 in Skyfarm. So we had a difficult time at that point of trying to figure out how to hack together some sort of access control. Don't do what we did and just sort of like pin it on top at the end. Think about that earlier so that you don't have this type of issue. Think about whether the whole company needs to be aware of all of the different devices you're working on, or if you can have some sort of separation there. Another aspect to consider, we did not have a hard time getting teams to actually put their devices in Skyfarm. And the reason is because we made it really nice for them. As I talked about updating firmware can be a really painful process to do manually. Through Skyfarm, you click a button, which is really, really nice. So people were happy to put their kits in the farm. What we were hoping, though, was people would put their kits in the farm, and now everybody has access to all of the kits. That was not the case. Everybody still had their own cluster of kits that they used, and they didn't want anybody else to mess with. And if anybody did mess with them, they would get really mad. So we actually don't have like one big farm that everybody is pulling from, one big pool. We basically have like 5 or 6 like mini farms that people are using. So consider how your team thinks about the devices. Does your team actually think of the devices as belonging to the company at large that anybody could use? Or are they really specific and being like, no, these are ours, don't touch them? Because you need to start breaking down those boundaries earlier rather than just sort of throwing all of your devices in a pool and assuming that everybody is just going to use all of them. Release management. Yes, so one of the things we did early on was we had a timeout system. So you can lease a kit for 5 minutes, let's say. So that sounds good in theory, but when you're actually automating tests and you lease it out for 5 minutes and your tests go longer than 5 minutes, your kit just disconnects and the rest of the tests fail, which was not, the best way of doing things. So think about how that's going to work for you. Do you want to do that? Or do you want to do a manual release process where you have to send the kit back, or the device, back to the pool? When you're thinking about sending it manually back to the pool, you have another problem. What if people don't do that? And that's where the next bullet point sort of comes in, having control over that release. So we actually built a CI/CD pipeline so that we had full control over when they're going to release back to us. And we made sure that they were going to release it back at the end of the test run. So we didn't have to worry about it coming in or it not coming back. We had full control over that. So that's another thing to consider. How do you get full control? How do you make sure that the device comes back to the farm? It doesn't just get lost somewhere. Ooh. Another aspect to consider is administration. How do you add your devices to whatever system you're going to be managing? Right now, we just use a CSV, or an Excel spreadsheet. We're looking at building an admin view into whatever we're going to be building next. But for right now, we literally just fill out a CSV. So consider about how you're going to be doing that in the future. When you have a new iPhone or a new Android device that you want to add to your farm, what does that look like? What is that process defined? Scaling. So this is the last but not least thing to consider is if you're building a system like this, and this is just like basic software engineering, but was obviously not something that we thought that heavily about when we built this, consider how well it's going to scale. What is the peak resource utilization? For us, if you're installing multiple firmware on multiple dev kits at once, that requires a lot of CPU. So we did not look at that, and we did not consider like, oh, maybe we should split out that process. So we had to scale vertically rather than horizontally, and also consider stateless versus stateful connections, right? So we had a database that we were using in the back end, and the big giant machine that was upgrading all of the firmware was just statefully connected to that database. We didn't like separate out those processes at all. So consider like maybe doing that so that you can just spin up new versions that'll configure your devices for you without any issue. So those are the lessons that we've learned. Those are a lot of the problems that we ran into. We are hopefully going to solve some of those in the future. Right now, I'm going to take a sip of water, and if anybody wanted to take a picture of this or anything like that, now is a good time. I'll also be sharing the slides after. So let's talk about a little bit about the future of device management. So I've talked a little bit about latency. We have some processes that are really latency intolerant, is the way I would put them. So we're looking at having some co-located hardware with the actual devices, so we can cache, let's say, big firmware packages locally with the devices, so we don't have to stream them all the way across the world. Another thing is we're looking at having separation of concerns. That aspect of scalability that I talked about earlier, of being able to have agents that are actually going to be updating the firmware for you, so you can scale horizontally rather than vertically. That is one thing we're considering. We're trying to figure out how to reduce the statefulness of our devices and trying to minimize that to a single location so we can have as many devices, as many agents as we might need to upgrade the firmware in as many locations as we might need. Another thing to consider is generic resources and not targeting towards a particular platform. Sort of as I was talking about with PS4, we had to rewrite a ton of stuff when we started working on PS5. If we had considered from the very beginning, like, we're gonna have probably more types of devices. We should not just target it towards one very specific type. That would have saved us a lot of time in the long run. We're looking at Windows. We're looking at how to configure Windows machines and what that looks like. For us, trying to think of things as generic and then having specific stuff co-located with them is one big way of getting around this. Scalability I sort of talked about, and then configurability is the last one. So I mentioned that our PlayStation studios have a different definition of health for us. Well, we don't just want to build one system for us and one system for them. We would rather just build one system, right? And so having a configurable definition of health for us has been really critical so that we can sort of say, hey, you can use this to manage your devices as well. So those are a lot of the lessons we've learned. These are the places that we're going next. I have plenty of time for questions, so if anybody has any questions, I can answer those now.
Thank you for the presentation. How many devices do you have in the mini farms?
I'm not sure if I'm allowed to say, but less than 1,000, I believe. So definitely more than 100, but less than 1,000.
What are the main difficulties in terms of implementation of the software? Did you have as a team, like which language or which architecture, or what was the most difficult? ¿Cómo se dice? Dificultad, the most difficulty problem.
Sure. So what was the most difficult aspect of like the programming aspect of like building this system? Yes. So trying to figure how much I can say. Definitely one of the biggest problems was that scalability issue that I talked about before. So we were writing most of this in Python, and the just scalability of building one large stateful machine that's connecting to the database and updating the firmware for everything, that is like the biggest issue that we ran into, because we couldn't just clone it to several locations. So I sort of showed earlier that we are also managing devices in India and Japan, and our cluster for where we're building our software is not in India or Japan, so that latency is an issue. Ideally, we would just clone something and have it there and just load balance it, right? But because of the way that we architected it, that was not possible. So when we're rethinking this and we're redeveloping it, really making sure that we have stateless machines that can be co-located there is the way that is going to fix that problem, or we're hoping is going to fix that problem.
Has the success of the project made it so that like the next generation makes it easier for you to find those settings and those toggles so that you can like do things easier, right? Like if everybody loves this, did you manage to convince enough of the different engineering teams to be able to be like, could we get like a side load of this or any of those types of things?
Yeah, so the success of this has definitely made it so that there are more people within the company who are trying to figure out how to build this, how to work on this exact type of thing. In terms of like settings and toggles and what you were talking about before, we definitely have a much closer relationship with the teams that build those than we did when we first started. Sort of in the initial phases, like in that 2017, 2016 era, we didn't have a whole lot of communication with those teams, so it was really hard for us to figure out what settings did what and that type of stuff. But over time, we've become a lot closer to those, so it's much easier for me to just message somebody and be like, hey, what do I need to set in order for this thing to not do the thing that it is doing?
I have a question.
Yeah.
Is there anything you can say about the relationship of Appium and Skyfarm?
Sure. Yeah, so we use Appium for our testing. And one of the things I know at the talk that I was just at just before this a couple hours ago about building your own like mobile device farm, and somebody asked about like globally, like if you are executing a device that is in the US and you have your executor in India, like what does that look like? Have you figured out a way of fixing that? And for us, we did a lot of experimentation, especially for like the next version of Skyfarm that we're working on, to figure out like how much distance is too much distance, basically, between the actual executor and the device. So Jonathan works at PlayStation as well, which is probably why he is asking this question. And one of the things that we're doing is we figured out that having the Appium servers close to the device and the drivers close to the device was really, really helpful, but having the client wherever doesn't really matter as much. So we discovered that, which allows us to sort of make the argument for if we had some co-located hardware with these development kits, we could actually increase our speed execution quite a bit. So that was one thing that we definitely learned as part of this.
Cool. Yeah, I think that's probably true for mobile as well, because the Appium driver tends to communicate with the device a lot more than the client script to the Appium server itself. So it's the place you want to optimize first, probably.
Yeah, definitely, like your experience may vary, but trying to test out having the Appium server local to the device and seeing like what that does to your execution time, that's definitely something I would recommend checking out.
Cool. Well, I'm glad we're ending a little bit early. So I'm going to make an announcement and then we'll clap for Zack. Apparently things are going well upstairs and people are ready for us to come and have the closing session of the day. So Diego has asked me to tell you after this, just go upstairs. Don't go walk on the beach or whatever because you thought you had extra time, because you don't have extra time. So that's where we're going next. And let's say thanks again to Zack.